So we are going to be looking at the fourth day of Unit 7, which is triangle properties, and we're talking about what's called the mean proportional theorems. And this has to do with right triangles, and we draw an altitude from the right angle down to the hypotenuse. So the mean proportional can also be referred to as the geometric mean. And when you set this up without a triangle, the geometric mean is the number that can make those two numbers proportional. So you'll have your two numbers, a and b, whatever they are, and then you'll fill in your variable x here on the opposite side. So notice that these two match here. That will be true for all of the mean proportional problems we do. So looking at the first example, find the geometric mean between 10 and 15. So when you set this up, you're going to put 10 over x and then x over 15. Or it doesn't matter, you could reverse these. It could be 15 over x equals x over 10. It would not matter, because when you do the next step here, which is going to be to cross multiply, you'll end up with x squared equals 150. You'll take the square root of both sides, and then we need to simplify 150 down. So that's 25 times 6, so radical 25, radical 6. And then your final answer will be x equals 5 square root of 6. So that is the only number that could be put in here to make these two numbers proportional. What I'd like you to do is try number 2, pause the video and give it a try, and then we will go through it. Okay, so when you set this up, you're going to do your mean proportional. So it's going to be radical 6 over x equals x over radical 24. And again, you could reverse the two numbers here, it wouldn't matter. And then when you cross multiply, you'll have x squared equals radical 144. Well, this is a perfect square. So oops, that came up backwards there. X squared equals 12, and then you'll square root both sides and simplify 12 down to get radical 4 radical 3, and your final answer will be x equals 2 radical 3. So when we are looking at a triangle here, we actually have 3 different triangles that will show up in our mean proportional stuff. So the first triangle will be the big one. That has 3 sides. So it's going to be the hypotenuse is D, the shorter leg is A, and the longer leg will be C. You then have this slightly smaller triangle where our short leg is Y, our short leg is B, our long leg is Y, and our hypotenuse is C. And then you have the small triangle on the left here where our short leg is X, our long leg is B, and our hypotenuse is A. And I know I covered up, it says B right down here. I know you can't see it. So when you set these up, to get your actual proportions here, again, you'll notice that this diagonal here, they all match. So whenever you set up a mean proportional problem, one of those pairs should end up matching. So the first one will be x over a, and that's going to be a over d. So it's the small triangle to the big triangle. The next one that we have written here is y over c equals c over d. So this is the medium triangle to the big triangle. And then the last one is going to be x over b equals b over y. And that is the small triangle to the medium triangle. And you can do any set of sides there will match up to make a proportion. And you'll notice that when you do it, that again, that diagonal matches for all the mean proportional problems. So let's look at the table we have here. So in this triangle, we have triangle RST. So it's the pointy corner, the right angle, and then the other corner. And that's going to be congruent to, or similar to, triangle, well, let's go pointy corner, which is R, right angle U, and S. And then the other one is going to be the little triangle has a pointy corner down here at S, a right angle at U, and the other angle at T. So you can set up a whole table here of values. So we'll have the shorter leg to the hypotenuse for RST is going to be ST over RT, which is 30 over 50. And then when you calculate that, that's actually a value of 0.6 for your ratio. If you do it for triangle RUS, you're going to have SU over RS, which is 24 over 40, which is again 0.6. And if you do that for triangle SUT, you're going to have UT over ST, which is 18 over 30, which is, again, 0.6. So what I want you to do right now is pause the video and try and figure out the longer leg to the hypotenuse and the shorter leg to the longer leg for all three of those triangles. Okay, so when you do the longer leg to the hypotenuse for triangle RST, you will get this, which has a value of 0.8. Triangle RUS will give you this, which again is 0.8. And triangle SUT will give you this, which again is 0.8. Doing the shorter leg to the longer leg, I'm just going to put them all up here, and they will all have a value of 0.75. So moving on to the next part here. So we want to try and set up a mean proportional for this triangle. So the first thing that you need to notice is that they give you the whole side and they give you the little part here. So this piece in the middle is going to be 6. And now when we want to set up a mean proportional, you need to kind of use those triangles, and it takes some practice to get good at. But one way that you can look at things is anytime you have a triangle set up like this, you can do the piece to the altitude equals the altitude to the piece. So for our first one, to find x, we can do 3 over x equals x over 6. That's a good way to start if you have those values. So this is actually the short leg to the long leg equals the short leg to the long leg of the small triangle and the middle-sized triangle. So when you cross multiply, you'll end up x squared equals 18. Square root both sides. And then when you simplify 18 down, you'll get radical 9 radical 2, which ends up being 3 radical 2 for our x value. Now for y, it's a little tougher to set up that mean proportional to get it going. So what I've done here is 9, which is the hypotenuse of the big triangle, over y, which is the long leg of the big triangle. And then I've done y, which is the hypotenuse of this inside triangle here, over 6, which is the long leg of that triangle. And then from there, you're going to cross multiply, take the square roots, and end up with a final answer of 3 radical 6 when you simplify that down. Again, it takes some practice to set up the proportion in the beginning, so we are going to practice that a lot as we move forward here. So what I want you to do next is pause the video. I want you to try number 2 and number 3, and then we will resume and go through them pretty quickly. Okay, so setting this up, again, we can look at the part to the altitude equals the altitude to the part to find our y value. And we know that this whole side is 12, which will be important in a minute. Oh, looks like I did x first here. So for x, we can do the hypotenuse here, which is the whole side, to the long side of the triangle equals, this is the hypotenuse of this triangle, to 8, which is the long side here. So you'll cross multiply, square root, simplify, and end up with 4 radical 6. For y then, we'll do what I said a second ago, where we're doing the piece to the altitude equals the altitude to the piece. You'll cross multiply, square root, simplify, and end up with 4 radical 2. For number 3, it's turned a little bit of a different way, but you can still do the piece to the altitude to the piece, and you'll end up with 3.2. There's no nasty radicals in there because x is not on the middle bar there. And then for y, it's also pretty easy because we know that y is going to be x plus 5, this whole side. So you can just add them together to get 8.2. So your homework for tonight is going to be the day 4 worksheet. Other than that, I hope you have a great day, and I will see you later.